In this video, we are going to record the lecture related to the continuous distribution. Whenever the random variable is discrete, we have the values of the random variable in integer forms. Like the number of students in class, the number of pages on the book, the number of users at an internet server. All these variables are discrete variables. But the height of the student, the price of a commodity, the value of an index in a market, and these are the continuous variable because this may have any number in between the interval, either in fractions or in whole numbers. Whenever we are discussing the discrete random variable, the distribution is called probability mass function. The distribution means the function of the probability is known as probability mass function. Probability mass function is what? Probability mass function, PMF. Probability mass function is a function representation of probability distribution. While whenever the problem and the random variable is continuous, the distribution is known as probability density function. So we will use the term probability density function. So what is the density function is? Density function is a probability function of a continuous random variable. While what is the probability mass function? Probability mass function is a discrete is a function related to a discrete random variable. So here the random variable is discrete, but the function is known as probability mass function. Here the variable is continuous, so that the function will be continuous. The variable will be continuous as well as the function will be continuous. Here the variable is discrete, the function may also be discrete. Function may also be discrete means we have integer values, like we have some number here, we have a number here. These are the discrete values, and by making the histograms, we can make this function as continuous. So it is artificially we are making the discrete function to the continuous if we are making the histogram. Now, as I told you, normal is a continuous distribution, and in normal distribution, our discussion will be related to the bell-shaped distribution. Probability density function, or the PDF is a function of continuous variable. Is a function of continuous variable is known as probability density function. Fx is a function, and fx is a positive valued function. It means it never be the below the x-axis. The function values are always be positive for all values of x. X may be positive, x may be positive, x may be negative, but the function is always be positive. Function will never be negative because it is a probability function, and probability function will never be negative. The probability between the two numbers a and b is equal to the area under the curve from a to b. So if you are interested to find out a probability from a to b in case of a continuous variable, probability from a to b, the probability itself is nothing, is an area in case of continuous function. So you have to integrate the function from a to b with respect to x. This is called area from A to B, or in other word, area in case of the probability density function is basically the probability from A to B. Probability from A to B can be obtained by integrating the function from A to B fx dx. Total area under the curve is 1, as all of you have the concept that the total probability is always be 1. So here we have a concept of total area will be equal to 1. Total area means, suppose a function is defined from the limit minus infinity to plus infinity. It is the limit of x, and we are interested to obtain the total area. Then total area can be obtained from minus infinity to plus infinity, from minus infinity to plus infinity, and the integrate of fx dx is equal to 1. This is basically the total area. The total area will always be equal to 1. If we are integrating from in the entire limit, the total area will be 1. If we are integrating any subset of this interval, a and b is what? A and b is a interval which is a subset of this sample space. This is a total limit of the variable, and this a and b is what? This a and b is a subset of this total limit. So if you are computing this area, so this will be smaller than 1 if it is a subset. If I'm saying that a is minus infinity and b is plus infinity, then this area will also be equal to 1. So this is the concept behind the continuous distribution. We have not to use the integration in this course, but we have to use the predefined and pre-computed normal table for computing these area. But these tables are already constructed using the concept of numerical integration. What the numerical integration is? Numerical integration is a technique of integrating a function without using the integration formulas. As all of you are familiar that integral of x dx is x square upon 2. This is called the formal description of the analytic integration. This is called analytic integration. But the another technique of integration is known as numerical technique. In the numerical technique, we do not need to implement the regular formulas or analytic formulas of integration, but by using the computer programs, we can integrate the function. So normal table is generated by using numerical integration. Second concept to the PDF is cumulative distribution. Cumulative distribution is known as CDF. So these two are a very important term in case of continuous function. One is referred to as PDF, stand for probability density function, and other of them is known as CDF, is called cumulative distribution function or the cumulative function. Cumulative function is what? In a cumulative function, we integrate. This cumulative function is basically a area. This is represented by capital F, and this is represented by small f. This is small f, and this is capital F. Small f is a PDF and is a regular probability function, is a cumulative function. In cumulative function, it is basically area. As I told you, is area. Area means we have to integrate the function from lower limit of the function to any point which is referred to as x. This is a small value x, and we have to integrate from lower limit of the function to the x. of fx dx. If we solve this integral fx dx, then the result of this integral is referred to as CDF, is a function. So we have a general formula for computing the probabilities. This is the area from A to B. This is not the area from A to B. This is the area from the lower limit to a point X. X may be any number. Suppose if I put A here, so this is the area from minus infinity to A. If we put B here, so it is the area from minus infinity to B. So area from minus infinity to A, area from minus infinity, this integral can be computed by how? This integral can be computed by f of B minus f of A. Why f of B minus f of A? Because f of B means the area from minus infinity to B, and f of A means the area from minus infinity to A. If I subtracted these two areas, then this is basically the probability in between A and B, or it is the area from A to B. So this is the concept behind this cumulative distribution. If we are interested to compute this area from 2 to 3, then we have to integrate the function from 2 to 3, and this shaded region is basically the area in which we are interested. So one way of computing this area in a continuous function is to integrate the function by 2 to 3. Another way is what? Another way is this. Suppose we have a function fx, a CDF, not PDF, we have a function CDF. And in this CDF, cumulative function, this is represented by capital F. Capital F is what? Capital F is the area from lower limit of the function to the point X. So whenever I am interested to find out f of B means f of 3. So f of 3 is basically representing this area. This is f of 3. What is f of 3? F of 3 is the area from lower limit of the function, which is 0 in this case, up to 3. This is f of 3 minus f of 2. F of 2 is what? F of 2 is this area. This is f of 2, vertical. The area shaded by the vertical lines is f of 2. F of 2 is the double shaded area. F of 3 is a horizontal lines area, which is shaded by red horizontal line. If I subtract these two areas, then I have the area which is shaded by light color, and it is covered by the small boxes. This is the required area, which is the area from 2 to 3. So a normal probability distribution is a continuous distribution, and then from normal distribution we have to convert it into the another distribution named as standard normal distribution. It is called standardization of normal distribution to standard normal distribution. Transformation of the normal random variable. Basically, in between the two, a transformation is involved, and that transformation is called Z transformation or Z scores. All of you are familiar with the Z scores. Then we have to consider the inverse transformation. Inverse transformation means the reverse use of the normal table. Then finally, we have a normal distribution approximation to the other distribution. Like from binomial distribution, we can proceed to the normal distribution if your value of n is large. If your value of n is greater than 20, then we can use normal distribution in place of binomial distribution depending on, this is called normal approximation to the binomial distribution. So this is the agenda of this remaining slides, and from here we are going to start the introduction. If it is a discrete distribution, then we have the discontinuous bars. As we increases the number n, the distribution becomes, bars becomes very closer and distribution becomes continuous. This is a continuous distribution. In a normal distribution, this is the function of normal distribution. In a normal distribution, we have fx is equal to 1 upon under the root 2 pi. This is the another form of the function. Under the root 2 pi, instead of writing sigma square under the root, we may write sigma outside the root. And then e raised to the power minus half and x minus mean upon sigma and a whole square of that, with the limit from minus infinity to plus infinity. This is known as PDF of normal distribution. PDF of normal distribution. So we have to standardize this distribution. Why we need standardization? Because if I am interested to compute the CDF, suppose fx, so I have to integrate this function from minus infinity to x. Then I will get this CDF. But the integration is not too easy because it contains two parameters. One parameter is mu, this is mu, and another parameter is sigma square. These are the two parameters of normal distribution. X is the variable of the normal distribution. This sign is x variable follows normal distribution with the two parameters mean and variance. This is the simple description of the probability density function of the normal distribution. We have not to find out the CDF of the normal distribution. The reason is predefined table is available of CDF. We have just to plug in the numbers into the table and get the required area and subtract the two consecutive areas so that we can obtain the area in between the two numbers. So this is the technique which we will use for completing the distribution.
सर एक बात समझ नहीं आई.
How can I write down the function of normal distribution? Random variable x is a continuous variable, and this symbol tilde is used for x follows, and n stand for the normal distribution. First parameter is mean and the second parameter is variance. These are the two parameters of the normal distribution. Properties of normal distribution. It is one of the very important thing how the characteristics of normal distributions are defined. The one of the very important characteristic of the normal distribution is a bell-shaped distribution. Bell-shaped distribution means is symmetrical like this. This is from minus infinity up to plus infinity, the distribution is symmetrical and the mean is in center. This is the mean. Mean is of the distribution is mu. So the central value is mu. This point is the mean of the distribution. Now, another characteristic of the distribution is total area is 1. If I integrate the function from minus infinity to plus infinity, I will get 1 because total probability is 1, total area is 1. Normal distribution is characterized by the two parameters. One parameter is mu and the other parameter is sigma square. So mu and sigma square, these are the two parameters, and without estimating these two parameters, we cannot find the probabilities of the normal distribution. So the first step is to estimate the two parameters and then use the function to calculate the probabilities of a specific range. It has asymptotic behavior. Asymptotic behavior means it never touches the x-axis. Whenever we are moving towards infinity, the function becomes closer and closer to the x-axis, but it never touches the x-axis. This is called horizontal asymptote. On the both side, from up to minus infinity and up to plus infinity, we have the horizontal asymptotes. The next characteristic is the middle point is the mean, and the middle point, which is the mean, is same as the median, is same as the mode. It means the central point is the mean as well as it is the median and it is the mode. All the three measures are identical in case of normal distribution. Maximum ordinate is 1 upon under root 2 pi sigma. Sigma is outside the root. This is the maximum ordinate, this height. If I'm interested to find out this height, this is called maximum ordinate, and the maximum height of the function is under 1 upon under root 2 pi. You can see that the maximum height is inversely proportional to sigma, because pi is a constant. The value of pi will not be changed. It is a constant, but the value of sigma will be changed. If we have a higher value of sigma, then the height will be smaller. It is reciprocal. If higher value of sigma, the height will be smaller. For the smaller value of sigma, the height will be larger. This is the smaller value of sigma. Width is small, width is high. If the width is high, means standard deviation is high. If the width is small, means the standard deviation is small. If the width is small, then the height will be large, because the maximum ordinate will be high. If the width is large, means the standard deviation is large, then 1 upon standard deviation becomes a smaller or maximum ordinate. So this is basically the inversely proportion to that. So in a normal distribution, the height will neither be too high nor be too small. It is called meso. In the previous lecture, I defined that mesokurtic, it is piletic, kurtosis is platy, and this is leptokurtic. The leptokurtic means very small standard deviation and a maximum ordinate is too high. Meso means moderate value of standard deviation and the moderate height. And platy means the very high standard deviation but a very low maximum ordinate. So this is basically the relationship of these things. Area under the any normal distribution within the k standard deviation of mean is same for any normal distribution regardless the value of mean and variance. This is one of the very important characteristic, and this characteristic in statistics is known as empirical rule. Empirical rule is what? Empirical rule is a rule which is a corollary of Chebyshev rule. The Chebyshev inequality define the probabilities in between mean plus minus k sigma. Here we are again describing the probabilities of in between mean plus minus k sigma, but empirical rule is specific for normal distribution, while Chebyshev rule is used for any distribution, whether it is normal or whether it is not normal. We can apply the Chebyshev rule. Now, what these probabilities are? So these probabilities are defined as probability in between mean minus sigma and mean plus sigma is 0.6826. This is the probability, or we can say that 68.26% observations will lie between mean minus plus sigma. This is under the empirical rule. If I am interested to compute the probabilities from mean plus minus 2 sigma, this area will remain same, 95.44%. And the probability in between plus minus 3 sigma, it is 99. It means almost all the observations within the normal distributions are lies from mean plus minus 3 sigma, because it contains 99.73%. Still 0.0027% observations are there which are lower than the minus infinity or upper than the plus infinity. The shaded region that is not enclosed within that, because we cannot move up to the infinities, so that is very small portion. Now, standard normal distribution is the next thing, and in a standard normal distribution, uh, we have to transform the distribution. How this transformation work? This transformation work if I subtract the mean from the random variable. In this transformation, x is the random variable, mu is the mean of that random variable, sigma is the standard deviation of that random variable. This transformation is already this is the z score. And this transformation, if I apply this transformation over this function, then x minus mean upon sigma becomes z. The distribution becomes very simple, and that distribution is referred to as standard normal distribution. So the table of standard normal distribution is given to you, and a very important characteristic of standard normal distribution is the mean of the standard normal distribution is always be zero, and the variance of the standard normal distribution is 1. So standard normal means, what is standardization? The standardization is the standardization of mean and variance. The mean will always be 0, standard deviation will always be 1. You can see in the graph, in center, it is the mu z, mean of z. You can see it is 0. So in center you have a 0, and this distance is the standard deviation, which is 1 unit. This is 1 unit standard deviation. So almost all the observations lie within minus 3.49 up to plus 3.49, because the table of z distribution is given to you from minus 3.49 up to plus 3.49. So this area will be 99.73%. And this area, this is a very smaller area. As I told you, this area is from 0.0027. This area is 0.0027 is an ignorable area, and we can ignore that. Now I'm showing you the table of Z distribution so that we will be able to complete some examples of normal distribution. Now you can see PDF. In this PDF, This PDF will be provided to you in hard copy if your exams are physical. If your exams are online, you can use this PDF as a reference. This PDF contains a formula sheet as well as the table of sum distributions. Or I can say that the table of many distributions. Uh, this is the first page of the formula sheet. It will be provided to you in the physical exams. And this is the second page of your formula sheet. This is the third page of your formula sheet. So these three pages will be provided to you in exam. All the formulas, because in statistical inference we need lots of formulas. So you can see the formula of confidence interval, the formulas of testing of hypothesis. Every time we have a different formula. This is the formula of t distribution, this is the formula of z distribution. You can see the different formula. We have to use all of these formulas here. I can make it clear to you. Now you can see it clearly. You can see this is t distribution for correlation. दिस इज z डिस्ट्रीब्यूशन फॉर प्रोपोर्शन. z का फार्मूला अभी आप थोड़ी देर पहले देख रहे थे कि z का फार्मूला कितना सिंपल था, x माइनस मीन अपॉन सिग्मा, लेकिन इस वक्त z का फार्मूला आपको कितना कॉम्प्लेक्स नज़र आ रहा है. ये t डिस्ट्रीब्यूशन का फार्मूला आपको नज़र आ रहा है और बाकी ये कोरिलेशन का फार्मूला है और ये स्टैंडर्ड डेविएशन बहुत एलिमेंट्री आपने पढ़े हुए हैं सारे. ये स्टैंडर्ड डेविएशन का सैंपल स्टैंडर्ड डेविएशन का फार्मूला है. तो ये फार्मूला शीट आपको आप देख लीजिएगा. इसको मैं कोर्स वेबसाइट पर एज ए पीडीएफ फाइल सॉफ्ट वर्जन अपलोड कर दूंगा ताकि आप इसको पहले से इससे अवेयर रहें कि कौन कौन से फार्मूलाज इस शीट में मौजूद हैं. उन फार्मूलाज को लर्न करने की ज़रूरत नहीं होगी क्योंकि वो फार्मूला शीट से आप देख सकेंगे. जो फार्मूलाज इस शीट पर मौजूद नहीं हैं वो फार्मूलाज आपको यू हैव टू रिमेंबर द फार्मूलाज योरसेल्फ. ये तो फार्मूलाज थे. टेबल आपको लाजमन प्रोवाइड किए जाएंगे. ये टेबल है नॉर्मल ये टेबल है रैंडम नंबर्स का. जो सैंपल्स मैंने लास्ट टाइम ड्रॉ किए थे हम इस टेबल को भी यूज़ कर सकते हैं इसके लिए. और ये नॉर्मल स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन का टेबल है. इसको अभी हमने यूज़ करना है. देखें टेबल कहाँ से शुरू हो रहा है, -3.9 ये रहा और ये 0.0, 0.1, 0.2 और ये 0.09. तो स्मॉलेस्ट वैल्यू ये है -3.9 ये रही. -3.90 से टेबल शुरू हो रहा है और ये जीरो दिखा रहा है आपको. लेकिन यहाँ छोटा सा एक साइन लगा हुआ है. इसका मतलब ये है कि जीरो अप्रॉक्सीमेटली यहाँ है, वरना अगर मैं 7, 8, 9, 10 डिजिट्स तक जाऊंगा तो ये कुछ नंबर यहाँ आ जाएगा. तो इट्स अप्रॉक्सीमेटली जीरो. तो ये और ये क्यूमुलेटिव टेबल है. आप देखिए जैसे जैसे हम आगे बढ़ रहे हैं तो ये एरिया बढ़ रहा है. यहाँ 0.5 पे आ गया, आधा हो रही है. 0.000 पे एरिया आधा हो गया. क्यों आधा हो गया? क्योंकि जब मैं यहाँ तक का एरिया देखूंगा तो आप देख सकते हैं. सॉरी, अच्छा मैं इस वक्त पीडीएफ में हूँ तो ये मैं पीपीटी वाली फाइल यूज़ कर रहा हूँ. ये आप देख सकते हैं यहाँ तक ये ज़ीरो है. ये हाफ एरिया होगा. तो अगर मैं इसको लिखना चाहूँ, देखें क्या लिखूंगा. इसको मैं यूँ लिखूंगा F0 इज 0.5. ये मैंने F0 लिख दिया और इससे आप समझ लें ये क्या किया मैंने इसका मतलब है इंटीग्रेट कर लिया. किसको इंटीग्रेट कर लिया? मैंने इंटीग्रेट कर लिया -इन्फिनिटी से लेकर और 0 तक. किसको इंटीग्रेट कर लिया? FZ DZ को. और इसको लिमिट रखने के बाद सब कुछ करने के बाद जो आंसर आया वो ये था 0.5. तो इंटीग्रेशन मुझे कुछ नहीं करनी पड़ी, ये पूरा इंटीग्रेटेड मुझे दिया गया था सारा का सारा. ठीक है, तो ये आप देख सकते हैं अभी जीरो आपके सामने आ गया ये. अच्छा, नाउ कमिंग, ये इसके पॉजिटिव साइड है. जब आप पॉजिटिव साइड पे देख रहे हैं तो ये यहाँ -इन्फिनिटी. सपोज मैं अगर एक नंबर यहाँ लिख रहा हूँ, दिस नंबर इज F पॉइंट कैपिटल F है 0.45. F.45 का मतलब क्या हुआ? ये रहा 0.4 और ये रहा 0.05. F.45 पे ये एरिया आ रहा है 0.67 0.6736 ये एरिया आ रहा है आपको। और अगर मैं और आगे चले जाऊँ जैसे 1.3 पे चले जाऊँ तो ये 0.9 पे आ रहा है। आप देख सकते हैं ये और एरिया आगे बढ़ता चला जाएगा। जैसे जैसे मैं यहाँ आ गया 3.9 एरिया 1 हो गया, तो ये क्यूमुलेटिव टेबल आप देख सकते हैं। बाकी ये आपको स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन का ही टेबल है, लेकिन ये नॉर्मेलिटी चेक करने के लिए हम यूज़ करते हैं इसको। इसको नॉर्मल स्कोर्स कहते हैं। ये टेबल भी बड़ा इंपॉर्टेंट है, इसको हम यूज़ करेंगे असेसिंग द नॉर्मेलिटी। डेटा की नॉर्मेलिटी चेक करने के लिए ये टेबल यूज़ होता है। कैसे यूज़ होगा इसकी एक एग्जांपल हम अगली क्लास में करा देंगे। नॉर्मेलिटी करने के लिए इसको यूज़ करते हैं। अच्छा, और आगे बढ़े यहाँ से तो फिर टी डिस्ट्रीब्यूशन आ जाएगा, एफ डिस्ट्रीब्यूशन, ये सारे डिस्ट्रीब्यूशन आने शुरू हो जाएंगे। तो आई एम नॉट इंटरेस्टेड टू एक्सप्लेन ईच एंड एवरी डिस्ट्रीब्यूशन। बाइनोमियल मैंने लास्ट टाइम यूज़, अच्छा आपकी क्लास में क्योंकि फिजिकल क्लास नहीं हुई थी, आपकी रिकॉर्डेड है तो वो आप देख सकते हो। ये बाइनोमियल का टेबल ये रहा मौजूद। आप बाइनोमियल की प्रॉबिलिटीज़ चाहिए तो आप इससे देख सकते हैं। तो अगर टेबल से कोई क्वेश्चन है तो पूछ लें, वरना मैं रिकॉर्डिंग ऑन करके वापस नॉर्मल पे आ जाऊँगा। जी, नहीं है कोई क्वेश्चन तो आगे बढ़ते हैं। जी, कुछ कह रहे हो?
इसमें वो माइनस वाली बात एक दफा आप दोबारा बता सकते हैं? पॉजिटिव वाली बात तो समझ में आ गई, बट माइनस वाली बात तो ऐसा क्यों है मुझे अभी तक
देखिए,
माइनस?
टेबल माइनस नॉर्मल की बात कर रहे हैं आप, माइनस इन्फिनिटी से प्लस इन्फिनिटी तो इसकी थ्योरेटिकल लिमिट है, लेकिन थ्योरेटिकल लिमिट में वो जो माइनस वाली पॉइंट है ना, ये हमारे पास, ये तो कहीं तक भी मैं ले जाऊँ, कितना ही लंबा ले जाऊँ, नहीं लेके जाते। तो वो जो टेबल आप देख रहे थे उसमें देखा आपने एरिया -3.9 से शुरू कर रहे थे और उसने 4 डिजिट तक एरिया 0 दिखाया था। इसका मतलब है ये होगा कुछ एरिया इससे बिलो का एरिया। तो माइनस इन्फिनिटी कुछ नहीं है, ये माइनस इन्फिनिटी ये है नॉर्मल डिस्ट्रीब्यूशन में। और ये भी यहाँ टच नहीं करेगा, ये यहाँ चलता रहेगा। और ये 3.9 उसने प्लस में दिखा दिया था आपको। तो ये एरिया जो थे ये वाले, ये अप्रॉक्सीमेटली मैंने बताया था 0.0027। अच्छा, इसको भी आधा करोगे तो आधा इधर चला जाएगा, आधा इधर चला जाएगा, तो ये और कम हो जाएगा ये, ठीक है। तो ये इतना कम एरिया है। तो हम जब भी इंटीग्रेट करते हैं, मिसाल के तौर पर अगर मुझे ये चाहिए, दिस इज 0, क्योंकि स्टैंडर्ड नॉर्मल के फेज में दिखा रहा हूँ, तो इन द स्टैंडर्ड नॉर्मल इट इज 0। अगर ये है मेरे पास 2.5, अब 2.5 तक का एरिया चाहिए मुझे, तो बस मैं इसको ये टेबल में 2.5 देख लूँ। तो टेबल में अगर मैं 2.5 देखूंगा तो टेबल मुझे यहाँ से लेके यहाँ तक का एरिया सारा दे देगा। ये एरिया, ये सारा एरिया मुझे टेबल दे देगा, ठीक है। ये डायरेक्ट आ जाएगा मेरे पास। लेकिन अगर मैं इन बिटवीन का एरिया में इंटरेस्टेड हूँ, सपोज मैं इस एरिया में इंटरेस्टेड हूँ, ये है -1.2 और ये है 2.5, और मैं सिर्फ इस ब्लू एरिया में इंटरेस्टेड हूँ, ब्लू शेडेड रीजन। और यही ब्लू शेडेड रीजन 1 - 1.2 से 2.5 तक का, या तो मैं इंटीग्रेट करूं, नहीं कर रहा, मैं सिर्फ देखिए क्या करूंगा, मैं सिर्फ नॉर्मल डिस्ट्रीब्यूशन में ये निकाल लूंगा, एफ ऑफ 2.5 माइनस एफ ऑफ -1.2। एफ ऑफ 2.5 का मतलब है ये रीजन, यहाँ से यहाँ तक का एरिया। ये मैं इसका कलर चेंज करके दिखा रहा हूँ आपको, इसका कलर मैं ग्रीन कर रहा हूँ। ये एफ ऑफ 2.5, ये सारा क्या है, ये ग्रीन वाला है, ये ग्रीन वाला है एफ ऑफ 2.5। और ये -1.2 पे भी एक रीजन आ रहा है, वो कौन सा है उसका मैं कलर अलग कर रहा हूँ यहाँ पे, और उसके लिए मैं ये कलर यूज़ कर रहा हूँ ब्राउन कलर। शायद आप डिस्टिंग्विश ना कर पाएँ, लेकिन ये जो ब्राउन कलर से मैं शेडिंग कर रहा हूँ, ये ब्राउन कलर क्या है, ये है 1.2। तो आप देख रहे हैं ब्लू कलर इतना बड़ा एरिया था, नहीं ग्रीन कलर, सॉरी, ग्रीन कलर इतना बड़ा एरिया था और ब्राउन कलर इतना एरिया है, यहाँ तक का ये सब ब्राउन है। तो अगर मैं ग्रीन एरिया में से ब्राउन एरिया सब्ट्रैक्ट कर दूं तो ये जो ब्लू शेडेड रीजन है ये आ जाएगा, यानी मेरी इंटायर प्रोबेबिलिटी मुझे जो चाहिए वो मुझे मिल जाएगी। So this is the technique which we have to use. Now moving to the presentation so that we cover the few problems of the normal distribution in the presentation. Suppose we are interested to find out the probability from 100 to 180. I want to describe this case by this graph. It is a graph of normal distribution, not a standard normal distribution. How I can say that? Because x is there, not z. It is minus infinity, it is plus infinity, and what you have to do, and in center what you have, in center I have 160, because in a normal distribution in center you have mean mu. It is given mean is 160, and we are interested to compute the region 100 to 180. 100 is where there may be 100, and it is 160, it may be 180. So I'm interested to compute this shaded area of this shaded region. So there are the two ways to compute this area. One way is to integrate the function from 100 to 180. Other technique is to use the table of distribution function. So here I used that table. So for using the z table, you first have to convert the x variable into z. This is called z transformation. Z is what? Z is z score, x minus mean upon standard deviation. So if you have to transform this x into z, so in this inequality, you have to subtract the mean from all the three sides of this inequality and divide the entire sides by standard deviation. The mean is subtracted from here, the mean is subtracted from here, the mean is subtracted from here, and divided by standard deviation. As you listen, in the case of inequalities, there is no effect of the inequality if we subtract any number from the either side of the inequality, from the all side of the inequality, and there is no effect on the inequality if we divide the inequality by a constant number. So that ratio of the inequality will not be changed. So the new terms that we have, the value of mu is 160 and the value of standard deviation is 30, is substituted here. In between here I have z, because this is the transformation. This transformation is used here. And then this number is minus 2 and this number is plus 2, 0.666. So you have to compute f of 0.66 and f of minus 2. This number is obtained 72.47%. If anyone have to, in the second part of this, you have to compute the area below 150. The same way you have to do. You have to subtract mu and standard deviation on the both side of the inequality. This is 1.04, and this can be written as f 1.045. Look this number into the F table, you will get the value of 8.8520. In this problem, two investment plans are given. In the investment plan A, giving us a mean return of 10.4 with the standard deviation of 1.4. Another investment plan B, it is giving us a mean of 11, mean return of 11 and the standard deviation 4. And the user is interested to invest in a plan where the return is at least 10%. So what is this at least 10%? At least 10% is the value of the Z score in which he is interested. The investment A, the probability of return higher than 10%. So we have to convert it into the Z. then it is 6.6293. 0.6293 is what? It is the value of the probability of getting the 10% or higher return. But in investment B, after substituting the mean and standard deviation, you can see that 59.87% probability we have of getting the return, which is 10 more than 10%. The investment A will be better as compared to investment B, because investment A will give you a better opportunity of investment. Final topic here is the normal approximation to the binomial distribution. You have to cover it yourself in from the book. And in the next session, I will give you the chance to complete if your queries, if you have. Otherwise, we have a quiz in the next session from the 3 presentations that are already uploaded there.